Hello and welcome back, and that's right, today we want to look at unofficial memory upgrades on the Synology DS1522 Plus, a very recent release from Synology, and much like a lot of other Synology solutions out there, if you go to the compatibility listings for this system from the official pages, you will see that Synology only recommend utilizing their own memory with this system. But oh, so many of us look at the price of Synology's branded memory and go, that seems awfully expensive, and some people look at the DDR4 ECC memory that the system arrives with from Synology, see brands like a Kingston, they see brands like Crucial, like Sabrent, and then decide, do you know what, maybe I'm going to go third party. Now, it's worth bearing in mind a few disclaimers straight out the back before we go any further on today's video. First and foremost, throughout this video, I'm going to try to do as few cuts as necessary to show everything's working with this angle. I'm going to hop from the laptop screen to the NAS as much as possible. The second thing to bear in mind is, because on this desk I have a laptop that is screen recording, I have a NAS that's populated with drives that we're going to be utilizing, and the microphone right there, there's going to be humming and clicking from drives and general vibration that is just going to be nearly impossible to remove from this recording. So I apologize if there is a persistent level of noise at the very base level of this video. I will try and clean it up as much as I can in post, but as much as you can see me mounting the NAS on top of a foam pad here to kind of eliminate some of that vibration, there's still some of it in there from the fan of the NAS to the fan of the laptop to that. So I apologize if any of that makes it through the editing. And the last thing I want to highlight is, what I'm discussing today is not within the remit of what the brand recommends you should do with your system. We are talking about unofficial memory upgrades, and in some cases exceeding the CPU manufacturer's recommended maximum. So what you are doing right now could potentially destabilize your storage or lead you to a situation where the brand will not be able to support you in the event of a system failure. So do know this and bear this in mind before you try to copy anything I'm doing here today, because again, this is a test. This is me showing what works and what doesn't, and you need to make sure that your data is as safe as possible with a multi-stage backup and ensuring that your whole storage system is as rigid as possible from any kind of threat or vulnerability or failure. Okay, so let's carry on straight away. So what is today's video going to be about? Well, I've got the system here on the desk with its default 8 gig of ECC DDR4 Synology memory inside. I've already set it up. I've got the screen there set up for it. In today's video, we're going to be testing 3 different kinds of unofficial memory upgrade for this system. The first one is going to be a couple of Sabrent modules here. These are DDR4 16 gig modules, so that again this can support up to 32 gig here, and these are heat shield wrapped DDR4 SODIN memory modules at 3200 megahertz performance speed. There, we're going to be testing those. After that, we're going to go for the more affordable one. We're going to be going for the Crucial memory sticks. Again, a couple of 16 gig sticks there, living within the maximum 32 gig limit, and these are 22666 megahertz performance sticks there. So again, slightly lower than that of the Sabrents, but lower in price, and they don't have that heat shield either there. And finally, we're going to be looking at the Kingstons. We've got a couple of 32 gig Kingston modules there, DDR4 2666 megahertz, and this is going to equal 64 gig of memory. So we still don't know whether these are going to work, and we still don't know whether any of them are going to work. So first thing first, let's go into the user interface, and again, let's go in now. Here we are on the user interface of this NAS. I've already logged in here, and as you can see on screen, there is the 1522 name there. There is the 8 gig of memory the system arrives with there, the official memory, and the whole system's pretty much ready to rock there. And it's worth highlighting again, I will touch on this again at the end of the video, but when you do set up your NAS with Synology Assistant, it's worth highlighting that what you can do is bench test and check the consistency of any memory that you utilize. So if you go onto the NAS that you want to utilize, go to the cog at the top first. From there, you can enable an option in Synology Assistant to conduct memory tests. Click OK when you've enabled it, and then you can right-click any NAS and then perform a memory test. Bear in mind, when you do this, it will make your NAS completely inaccessible for a little period of time, so do bear that in mind. But if you are concerned with the consistency of any memory in your Synology NAS, official or otherwise, because I would recommend utilizing this regardless, then I do recommend utilizing that tool. But for now, let's shut down this NAS and start getting ready for our first memory upgrade, those Sabrent modules. So let's go ahead and make our way back to the other camera now, and here we are. So again, these are the Sabrent memory modules. These are going to be featured in pretty much every memory test that we do here on the channel for a while. And the reason is that even though they're a pinch more expensive than some of the other memory modules in the market right now, what I like about them is, one, they are priced incredibly similarly to 2600 and 2400 memory modules, but it is that heat shield there on the top. And I think the heat that memory achieves, particularly in servers that are in 24/7 use, is, you know, hugely overlooked. And again, I touched on this already earlier on, but this memory is non-ECC, but the memory that this NAS arrives with is ECC. Now, ECC, or error correcting code, or error code correction, is memory that when data passes through it, it checks at the beginning and the end the shape of the data. And if the data has any inconsistencies during its time through the cache, the buffer space there, it then repairs that data to its original form, and therefore eliminating any inconsistencies in the write of the data to the system. ECC has an enormous appeal when it comes to enterprise level servers, and again, fair play to Synology for including it in a NAS that's frankly quite modest in its scope. So what I'm going to do now is start removing these. Normally, I would not recommend removing drives from a NAS this soon after a power down, but again, I don't want to have you guys waiting around too long, so I'm going to be as careful as I can be. The memory modules for this system are tucked in on this angle here, and I will add most of the drives in this NAS are, you'll see in a moment, we have a Synology drive here, we have another Synology drive here, and inside we are running tests very, very soon using Synology's own drives and third-party drives as well. So as you can see, there are memory modules there on the side. I'm going to remove the power from the rear of this. Always do that when you're doing any kind of testing or upgrading of a NAS. You can see the little slots in there, and there's one Synology slot just inside there. Again, you may also have noticed that I have the Ethernet cable. I'm directly interfacing with this system rather than going through a switch. It can sometimes mean the system accessible a lot quicker. So again, let's remove that one module. So this will be Synology's own 8 gig module, as you can see there. And that is an ECC 3200 megahertz module there. But again, it's that ECC that's the most important. I'm going to pop that there. And then we're going to start including our Sabrents. Let's get those in there. Let's get that the right way around. There. It's a terrible angle to be doing this. I might fast forward this. There we go, both modules are inside, as you can see there. Sorry that took a little longer than expected. That was largely because, and I've touched on this before, that as good as that heat shield is on the Sabrents, it makes them slightly fatter. So when you have them slotted inside, it really is quite a precise engagement to get them inside and making sure they're both clicked in. But let's reinstall those drives. Put those in there. Put that there. I'm sorry about banging the mic there. Got that ready. Let's reinstitute our power. And boom, let's start our NAS. So again, the amount of time this is going to take to boot will vary, because much like I've done some tests with DS7.1 a while ago, sometimes memory modules will take longer than others for the system to reinitialize and recognize them on a BIOS level. Now again, that was an error I made, hands up on that one, but that's something that since then we have made sure to stay abreast of. So if whether this system boots or not, we will give it a good 10 to 20 minutes if we need to, and I will fast forward if that's the case. But normally the big clue during the booting operation of a NAS, with or without any kind of upgrade of official or unofficial memory, is normally when we hear those drives kick in. Because when the system initializes, it's doing an internal check log of all of its systems, operations and ports, and then it activates those drives. So right now the drives are not spinning, but eventually we will start to hear them, and you will hear these drives click, come and whir as they kick in for initialization there. But for now, I think we may have to wait a little longer for this system to initialize. Let's put that around there, And what I'll do now is I'm going to fast forward until the completion of this thing's boot. Yeah, there we are. Didn't even need to fast forward. Look at that, jinx. So we've got our green little lights flicking away there. It looks like we may be cooking with gas very, very soon. You are going to hear those drives shortly. And when we hear the beep, what we'll do is we'll refresh that page on there. While it does that, I think it's worth touching on the subject of third-party memory, because when you are looking at getting third-party memory for any NAS system, not just the Synology, you may have noticed an enormous inconsistency in the pricing. You can get an 8 gig DDR4 sewed-in stick for as little as 20 quid, and then some companies are selling them for 30 or even 40. And a lot of that comes down to the provider of the memory modules, that little NAND flash modules that are on the board, but also the construction of that PCB as well. And generally, when it comes to buying any third-party NAND, the lowest, and I do mean this, the lowest of the low prices that I'll go is normally for Time Tech, maybe ADATA as well, because ADATA's got a good rep in memory. They do SSDs as well, of course, with the modules, but I wouldn't really go lower than that. Okay, so again, Time Tech is currently the lowest price memory on the market right now that I would consider worthwhile, that I've tested on multiple NAS systems. But for now, let's make our way over to the screen. 3, 2, 1, and go. And here we are. Let's refresh that tab there at the top and log into our NAS. Hope it'll stay signed in. And what we want to see there on the screen, go into the control panel and boom, let's go to the info center, and there we go. We are seeing our 32 gig of memory. I looked at the wrong camera there. And again, we can go to the resource center there and have a little look. And again, we're much like our video on the DS2422 Plus, we will be doing a little bit more digging into the usability of the memory. We're not going to worry too much about this one because we knew this CPU could support 32 gig. But if we go to the memory option there, we can see that it's utilizing, we've got that buffered cache there in the background. You know, we have that, and we've, you know, Synology has a very intelligent cache utilization and flushing system there in the background. But for now, I'm seeing that memory working, and for me, I'm going to call this a success personally. So let's go ahead and shut this down and get ready for our next test. So we shut that down. Hopefully we're going to hear a beep in just a moment. And our next modules are going to be, again, 16 gig modules, but this time they're going to be the crucials there. So pop that there on the side. We made our way back to our other camera. And for now, we're just going to wait for this system to just put itself to bed there. We're going to get ready with our crucial modules. And again, we will give it just a little minute after it shuts down in order to check that. One of the things I never really take the time to compliment Synology on, because I'm sure they're not huge fans of videos like this, where we're testing third-party memory. But one enormous compliment I've got to give to Synology and their systems is the speed with which they boot up and boot down. I think it's a hugely overlooked thing about Synology NASs, and most people never know because they buy one NAS every, maybe every 3 to 5 years, if that. So they never really see just how quick their systems boot up and boot down. Once again, we remove our power and remove from the rear. Remove that module there. Again, we're going to be very delicate. Once again, just be careful the way you remove drives this quickly after a boot down or a shutdown even. So we're going to put that out there. Remove that. We're going to remove our rocket memory there. So go and stick our hand inside this system. That feels safe. There is our first module. Once again, that heat shield has already got quite warm there. Remove another one. It wasn't even on for that long, this system. There is our other rocket module. And again, now we are looking at the crucial DDR4 16 gig. These links should be in the description to the memory that we're utilizing today, as well as the links to the larger article that has all of the different NASs we've tested with different NAS brands. Let's get these modules in here. That is so much easier without the heat shield on there. Just pop that in that slot. Wheel clicked in. Yep, all clicked in. Let's bring that close to shot for you. There is that crucial memory inside. Let's get those drives back in. Pop that there. And again, I've got high hopes for this. We tried crucial memory before, and although it's not that ECC memory inside, that CPU has never really shown us any problems with crucial memory up to this point. So pop that there for that. We've got our power back in. I hate seagulls. Put that there, and now we can power the device. Again, I've got relatively high hopes for these crucial modules here. I think we're going to be absolutely fine there. Now, while it does that booting, let's talk about another thing. Why would you want to upgrade the memory on your NAS? Because, you know, these systems are pretty darn competent when you first get them. They run a whole gamut of operations and apps inside. They have intelligent cache and memory management inside. Why would you upgrade the memory? Well, upgrading the memory can do several things. One, it means you can run more apps simultaneously and have more active users simultaneously. But when you are running large file operations, predominantly write but also read is a factor too, you do find that the more memory you have, the smoother things are going to be, with the added benefit that Synology's NAS or DSM as a whole has quite smart memory handling. It will typically use more memory than it needs to. Now, I know how bad that sounds, but hear me out. The result is that if you have an 8 gig memory module and you're doing an operation that might need 1 gig of that memory, generally they'll give as much memory needed to keep the process as fluid as possible. It will use the resources that are on the table as much as it can in order to allow you to do even more. And later on, if you're running more apps that need that memory that you wanted to keep available, we just heard the drives kick in, then it will free up and it will flush that cache intelligently as needed. So rather than having a big area of memory doing nothing until it's needed, it will overspec the amount of memory it needs per process until it realizes it's getting close to using up the memory, and then it will start to intelligently flush the unnecessary or the overspec memory allocation there. So it's a great way in which the system intelligently over provisions for a lot of operations, but then will rescind that as needed without any intervention from the end user there. But we just heard a beep, so let's hop our way back into DSM. The IP shouldn't have changed because we're patching directly in once again. That is the reason we're doing this rather awkward cat setup here in front of us. We can log straight in, and I'm fairly certain we're going to see that crucial memory there. Again, there are lots of different kinds of crucial memory. Do bear in mind that you want to go for DR memory, which frankly at 16 gig they're all going to be, but make sure you go for dual rank or DR memory. Okay, SR, leave it, get away from it. So we head into the manager here. We go into the info center. From the info center, boom, there's our 32 gig of memory. The system is operating as normal. Again, after a while, when the system is running for a while with unofficial memory, do bear in mind that eventually the system will flag there on screen. I'm going to stop looking camera to camera. But eventually the system will flag the memory as not on the compatibility list. Unlike drives that appear on the non-supported compatibility list, not officially supported, which appear immediately on the memory bar there. When it comes to, on the notification bar, when it comes to third-party memory, it generally takes a little bit longer for the system to know that you're using third-party memory. So don't assume that just because at the top right there, or on the notifications panel, that it's not warning you, that it's never going to. It will eventually know that you're using third-party memory there. But for now, I'd say that was a success. So let's, for the third and final time, let's shut down this NAS. And now what we're going to be doing as I hop back to the other camera now is I'm going to remove that and make our way onto arguably the most controversial memory that we're utilizing. Not that it's Kingston, that it's 32 gigabyte DDR4 modules, 2 of them inside there. This is way outside that 32 gig recommended maximum that this system has from Synology and indeed from AMD with that embedded Ryzen R1600 processor inside there. The system is powered down. Once again, Synology with your quick shutdown system here. Again, the more you're using the system for, that will differ. Let's remove our power there from the rear. Let's remove our bays. Remove that again, be gentle. Pop that there. Get our next one there. And we'll start making our way into those memory modules there. So again, we'll pop out that first stick. Crucial stick number 1. Go for our second one. Before I've done this, I should highlight I've not tested this yet. I think this will work. or at least the memory modules will be recognized by the system. After that, it's kind of out there in the unknown. But I think this will work. But for now, what I'm going to do is get our modules. I'm going to have to angle that around. Be very gentle with it. Get that inside there. Once again, I apologise for how much of this video is you basically looking at the top of my head. Let me know if I'm going bald, by the way. Maybe I'll notice in the edit, who knows. We're all getting older, aren't we? Let's pop it in there. That was my elbow. Totally didn't hurt, honest. There we go. So we've got our two 32 gig modules installed inside our system. Let's get our drives back inside. Hopefully the battery on this laptop will survive long enough. Let's go for that there. Put that inside there. And yes, I'm running the laptop on a battery because then the fans would kick in otherwise, and that would be super annoying. So pop that inside there, and for now let's go ahead and kick it on. Right, so while it does that there in the background, why on earth would you want 64 gigabytes? That does seem ludicrous, doesn't it? Well, there's a few reasons you would want to use quite a substantial amount of memory. The first and easily most obvious one is a virtual machine. Now, this is a 2-core 4-thread x86 64-bit processor inside this system. So, you know, the extent to which one could push a virtual machine is a little bit more limited, arguably. But when it comes to containers within Docker, you are going to be able to stretch your muscles just a little bit there than you might think, a lot more than you might think. On top of that, if you were going to utilize this system for surveillance, something I think a lot of users actually would do, then that amount of memory can be very, very useful for those high-spec cameras, particularly when you're using a non-embedded CPU there. Having more memory is going to be very, very useful. In large-scale surveillance operations, you generally are recommended to be starting with 8 gig with as little as 4 to 6 cameras, simply because there's a lot of memory and indeed CPU consumption when it comes down to surveillance. And given this system can support, I believe, between 25 and 40 cameras, of course you're going to need licenses, that is a lot of memory. And the 32 gig is probably enough for that, but what if you're going to be running other operations? So there are reasons that you may want to hit those bigger numbers. But then, of course, it comes down to, can the CPU even see 64 gig? Because just because you can see 64 gig recognized by the system control panel does not mean that you can actually allocate tasks and use more than 32 gig at any one time. When Intel or AMD make maximum recommended specifications on memory upgrades with their CPU, there's the beat there, so we've got some boot and we've got the lights. A lot of the time it's because, you know, you are using the max number of channels. You are using the, you know, the PCI lanes, and the build of these CPUs simply cannot handle that much more at any given time. So it may be that you might put 64 gig inside, and maybe in a kind of loosey-goosey fashion you can, you know, hit 48, maybe, you know, hit 42. But the odds of being able to fully utilize 64 gig on this system are nigh on impossible, to be perfectly frank. So let's go in and head back to our other camera. Refresh there, because let's face it, I think we can all agree we're almost certainly going to see that 64 gig appearing here on the screen. And as we log into our NAS there, again, we've got a slightly slower login there because I've put the wrong password in. I'm too conscious of that battery running out at the bottom of the screen there. But as we go down to the control panel, go into the information center, and boom, there is our 64 gig showing. Now, once again, just because it's on there does not mean it's always, you know, you're going to be able to allocate that full 64 gig. And me personally, I would not recommend going this high and thinking you're going to get the 64 gig. Notwithstanding Synology's own stance that you shouldn't be using third-party memory, I think 64 gig is still pretty much overkill for this system, particularly with that CPU inside. But still, the fact that you can at least acknowledge that the 64 gigs inside there, it'll be very interesting to see how allocation would even work being outside of the CPU manufacturer's own recommended maximums. And once again, regardless of whatever memory you use in, you know, your NAS upgrade, please take advantage of that memory test feature there. It will put the NAS out of commission for a little while it runs those tests, and the more memory you have, the longer it's going to take but you will see the benefits of it in this, and particularly when you're using larger cache areas, large amounts of memory can even work more than you would think. So this has been my unofficial memory upgrade video for the DS1522 Plus. All the memory utilized was recognized by the system, but again, we still don't know without further testing, which is something we are digging into in a far more aggressive fashion, just how far we can take that. We know we can, from previous videos, allocate 60 gig to a virtual machine if we choose, but it's whether it's actually able to take advantage of that, which is something we're going to have to deep dive into. But otherwise, thank you so much for watching. I hope you've enjoyed this video. Click like if you have, subscribe to learn more, and there's links in the description to all of the memory modules we've used today, the NAS we've used today, and a full guide breaking down every single Synology NAS and memory modules, first and third party, that we have tested. Otherwise, thank you so much for watching. Use the free advice section. I will see you next time.